Okay. February, March 2019, paper 1, variant 2. Question 1. Yeah. Um, table shows the volume of water in the cylinder, صح? For every minute for 4 minutes. What is the average volume? How can I find the average volume of water collected in the cylinder each minute? Okay, each minute. How can I find the average volume collected each minute? Average anything. For example, when we say the average speed, how do I calculate the average speed يا شباب? We always say the total distance over total time. That's the average speed. What about the average volume? Mister, there's no equation for the average volume. صح? Well, we can find the average volume. How can we find the average volume? It's simply, we just need to divide the total volume by the total time. The total again, the total volume by the total time. What's the total volume for this question? Okay, what is the total volume? شباب, the total volume, you cannot add 0 plus 27 plus 57 plus 80. That's not the total volume. لا. The total volume is the final volume we reached. Okay, we had the measuring cylinder. Okay, the volume kept on increasing. It kept on increasing, kept on increasing for a total time of 4 minutes. After 4 minutes, okay, after 4 minutes, we reached a total volume of what? Of 112 centimeters cubed. And we took a time of 4 minutes. To find the average volume, what should we do? Simply 112 divided by 4, which would be 28 centimeters cubed. So on average, each minute, we added 28 centimeters cubed of water. Okay, total volume over the total time. The total volume is just final volume, and total time is just the final time. Okay, yeah, I hope that's clear. Yeah. An object is moving with a uniform deceleration. Yeah. What does deceleration mean? In which statement? It's the rate. Okay, its rate of change of speed is decreasing. Hmm? Its rate of change of speed is decreasing. A lot of you actually would choose this answer. A lot of you would choose this answer. Okay, but sadly, it's wrong. Sadly, this answer is wrong. Okay, it's actually, yes, a lot of you are actually saying C, which is the correct answer. The speed is decreasing. Yeah, Mr. Tab, what does it mean? The rate of change of speed is decreasing. The rate of change of speed, okay, the rate of change of speed by itself means the acceleration or the deceleration. This statement, this statement means the acceleration or the deceleration. So, in other words, we can say that its acceleration is decreasing. And he actually said that its acceleration or his deceleration is uniform. So this has to be wrong. The right answer for this question would be C. The speed is decreasing. Speed is decreasing. Okay. Yeah. Question 3. A ball rolls down a ramp. Time it takes, okay, to move from X to Y is measured. So we measured the time. We found the time. The time is measured. which which other quantity must be measured in order to find the average speed? Yes, we know that the average speed is total distance over total time. We need the distance. We need the distance. We already have the time, so we need the distance between X and Y. Yes, excellent. All of you are solving it correctly. Yeah. Question 4. An astronaut in space, okay, in a space station orbits above the Earth. The space station, the acceleration is what? 7.5 meters per second squared. On Earth, the gravity is 10. We actually know that it's now 9.8 meters per second squared. This is an old exam. So it's actually what? 9.8 meters per second squared. Anyway, in the space station, the acceleration is 7.5 meters per second squared. What would happen to the mass and what would happen to the weight? The mass, does it change? No, stays the same. Yes. What about the weight? The weight would be less. Yes, bro. Yes, weight equals mg. The g in this question would be less. Instead of writing 9.8, we would write down 7.5. So, yes, the weight would decrease slightly. Yes, excellent. Okay, question 5, we solved this question before, but let's solve it again together. We have the total mass of the bottle and, okay, the bottle of oil, and the oil is what is 1.3, 1.3 kilograms. When you removed half of the oil, okay, half of the oil was used, okay, we removed half of the oil, the remaining mass was 0.9 kilograms. So basically, half of the oil, half of the oil is equal to what? Is equal to the difference between them, which is 1.3 minus 0.9, 0.4 kilograms. This is half of the oil. He wants to find the mass of the empty bottle. How can I find the mass of the empty bottle? I just need to remove the second half. So how can I remove the second half? Very simply, 0.9 minus the second half, which is the remaining half. This is 0.4. And the initial half was 0.4. You already removed the 0.4. You already removed 0.4 kilograms. So can I remove the second half? Yes, I can remove the second half. Subtract 0.9 minus 0.4. This would be 0.5 kilograms. Yes, excellent. Okay, yes, you all said B. Correct. Okay, you have a question. What's your question?
يا مستر أنا مش عارفة عملنا ايه اصلا.
ايه؟
انا مش عارفة احنا عملنا ايه.
طيب again احنا initially we had a full bottle, okay, we had a glass bottle for example which had some oil inside it, okay, a glass bottle with some oil inside this bottle. The glass bottle itself has a mass and the oil inside this glass also has a mass, صح؟ طيب when
Yeah.
you measured the mass of the oil plus the glass, the initial mass was 1.3 kilograms, 1.3 kilograms. When you removed half of the oil, only half of the oil, the remaining mass was 0.9 kilograms. So you
Yeah.
removed how much? What was the difference?
0.4.
So this is half of the oil. This is half of the oil, 0.4 kilograms. صح؟ طب what if I removed the remaining half of the oil? What if you remove the remaining 0.4 kilograms? You want the bottle to be completely empty. When you removed the remaining 0.4 kilograms, the empty bottle would weigh, or the mass of the empty bottle would,
0.5.
that's it, 0.5 kilograms. Okay?
Okay. Thank you.
Okay, you're welcome. Yes, question 5. Okay, question 5. What is the mass of the ball? I have the volume, okay, and I have the density. How can I find the mass? Density equals mass over volume. This is quite easy. So mass equals density times volume. Mass equals density. What's the density? 1.6. And what's the volume? 4. 6 times 4 times 1.6 is 6.4 grams. This 6.4 grams. Yes, excellent. Question 7. Which property of an object cannot be changed by applying a force? If I apply a force, can I change the volume? Yes, you can change the volume. Can you change the speed? And changing the volume by compressing it, for example, or breaking the object or whatever. Can I change the speed? Yes. Can I change the shape? Yes. I cannot change the mass by only using the force. Okay, you cannot change the mass. So it would be A. Okay. When an object of an unknown weight is suspended on the spring, the length of the spring is 16.4 centimeters. What is the weight of the object? Initially, the unstretched length of the spring was 15 centimeters. Okay, the unstretched length was 15 centimeters. Can I find the extension? For this question, can you find the extension? Yes, it would be quite simple. How can you find the extension? All you need to do is, okay, initially you need to subtract 16.4 minus 15, which would be 1.4. So the extension, okay, how to find the extension? You need to subtract the extended length, okay, the new length minus the original length, the extended length minus the original length. So 16.4 minus 15 is is 1.4 centimeters. From the graph, okay, you need to draw a line. You need to draw a horizontal line from 1.4. Yeah, drawing a line from 1.4 all the way till it reaches this point. And then you can draw a vertical line, which would be 3.5 newtons. Yes, 3.5 newtons. Um, okay. Great. Okay. Yeah. Question 9. The diagram shows a wooden beam with two forces acting on it. A wooden beam with two forces acting on it. How can I find, or in which way will the beam move? In which way will the beam move? Can I explain it again? Question 8. Yes. Okay. Question 8 again. All you need to do is find the extension. How can you find the extension? Extended length minus original length. From Okay, he stated above that the original length, the unstretched length, okay, was 15 and the extended length was 16.4. Simply 16.4 minus 15 is 1.4. From the graph, you need to draw a line from 1.4. This is 1.4. You need to draw a line, a horizontal line, until it reaches the line, until it reaches the curve or the graph or whatever, and then draw a vertical line until you reach the x-axis, which would be 3.5 newtons. Okay. For question 9, this is a really nice question. In which way will this beam move? In which way will this beam move? If you take the pivot, for example, if you take the pivot, for example, to be at this point, okay, I'll take the pivot at this point. You will find that the force, okay, the 5 Newton force will apply a greater moment in this direction than this 5 Newton force. Okay, it will apply a greater moment in this direction. What is this moment? Is it clockwise or anti-clockwise? We know that the clock turns this way, so this is a clockwise moment. Yes, so the 5 Newton force will apply a clockwise moment. So it will turn clockwise. طب يا مستر, what if I didn't take the pivot at this point? What if, for example, I took the pivot and to be at the middle? In the middle. هنا, exactly, in the middle. What if I took it to be in the middle? Again, this force, okay, the 5 Newton force wouldn't apply a moment أصلا. Why wouldn't it apply a moment? Because the distance is 0, so this force is cancelled. What about this force? Again, it's applying a clockwise moment. Okay, what if I took the force or the pivot to be at this point? Okay, so this force would be cancelled. Why? Because it's exactly on the pivot, so it wouldn't exert any moment. What about the other force? Now it's exerting a clockwise moment as well. So wherever you put the pivot, okay, wherever the pivot is put on this beam, it will exert, okay, it will turn in a clockwise moment. It will turn in a clockwise, okay, rotation. Okay, and whichever point, whichever point you put the pivot, مثلا if you put the pivot here, if you put the pivot here, okay, at any point, it will turn in a clockwise moment, okay, clockwise rotation. Okay, I hope this is clear. Okay, this is the clockwise one. Can you mesh? Okay. Yeah. Which source of energy uses the production of steam to generate electrical energy? Steam to generate electrical energy. Hydroelectric doesn't have any steam. Hydroelectric does not have steam. Yes, nuclear, because we boil the water, which produces steam, and then the steam goes into the turbines. Yes. What is the unit of power? Quite easy, huh? The watts, definitely the watt. Yes. Question 12 is cancelled. Yeah, question 12 is cancelled. Yeah, question 13. Yeah, this is really easy. Exerting the least pressure. How can I decrease the pressure? The least pressure. How can you decrease the pressure, شباب? By increasing the surface area, by increasing the area in contact with the ground. It would be, yes, it would be B. C would have the greatest, it would have the greatest pressure exerted, but B would have the least pressure exerted. Yes, bravo. Thank you. You have a tire, okay? Okay, you have a tire, and now You have a small hole in this tire. Why does the air leave the tire? Why does the air leave the tire? Okay. The pressure, it has to do with the pressure, definitely has to. It does not have to do with the temperature at all. C and D are cancelled. The pressure, is it greater or is it less? Yes, it has to be. Yes, it has to be greater. Inside the tire, it has to be greater than outside. That's why it always moves from the greater pressure to the less pressure. Okay, it always moves. For example, anything. Sure, that's the normal motion from the high pressure to the lower pressure. Yes, it has to be A. Bravo, bravo. I'm really glad. Question 15. Question 15 is a bit tricky. Okay. Question 15 is a bit tricky. Okay. How can we solve 15? Okay. How can we solve 15? It's honestly really tricky. On a cold day, on a cold day, a metal measuring tape graduated in millimeters is used to measure the distance between two fence posts. Okay. So you have two fence posts and you measured the distance between them on what? On a cold day. On a cold day. The distance between them was 3 meters. Okay, it was 3 meters. This was on a cold day. On a much hotter day. Okay, on a much hotter day. Okay, so now you have the measuring tape. Okay, it's like a ruler. Okay, it's a long measuring tape. Okay, a long measuring tape. It read a distance of 3 meters, all the way from 0 to 3 meters. Now, on a much hotter day, the metal measuring tape, okay, is used. Okay, we use the same measuring tape, but the metal has a much higher temperature than the ground. The metal now has a much higher temperature than the ground. What will happen, okay, when you think about it, what will happen to the metal? It's a good conductor, so it gets hot, okay, it gets too hot, so it expands. صح? We know that the metal will expand because it's now really hot. The metal will expand because it is it's really hot. So instead of reading 3 meters, what will happen? For example, if the distance was 3 meters and this measuring tape is now extended, okay, thermal expansion, it's now actually longer. This measuring tape, يا شباب, is now longer than 3 meters. So when you measure the distance between the posts, what will happen? The distance on the measuring tape will be less. Okay, on the measuring tape will be less. Again, the measuring tape reads less. It wouldn't read more. Okay, it will not read more. It will actually read what? It will actually read less. Why? Because the distance between the posts has not increased. Okay, the measuring tape has expanded. The measuring tape is now a bit longer than 3 meters. Why? Because it has expanded due to the temperature, due to the very hot day. Okay, now the measuring tape expands, and the length is longer than 3 meters. Like, how can I choose the right answer? Because the graduations are closer together, or because they're further apart? When it expands, the distance between each of these two graduations, for example, we have these two graduations, the distance between each of these two graduations, what happens to the distance? It gets further apart. Distance between each two graduations gets further apart. Again, what happened? Again, what happened? The measuring tape got hot, so it expanded. The distance between, for example, the 10 centimeters and the 20 centimeters wasn't actually 10. No, the distance actually increased. Okay, it distance increased. It didn't get less. لا, you said no. The distance. What happened to the distance? It actually increased. Why? Because the temperature increases and expands. It expands due to thermal expansion. When the distance increases, okay, it will read a much less reading. For example, if you use the same measuring tape now, it will read the distance of 2.5 meters, for example. Okay. For example, it will read 2.5. Is that right? No, it's wrong. Why? It's wrong. Why? Because actually the measuring tape needs to cool. Okay, the measuring tape needs to be a bit cooler for you to take the actual reading. Okay, it expands, so the reading will be higher. No, it expands, so the reading will be less. Okay, actually, what you need to think about it this way: what's the thing that actually expanded? Okay, what is the thing that actually expanded? Is it the ground, or is it the distance between the posts, or is it the measuring tape? Okay, or is it the measuring tape? Okay, he said that the measuring tape has a higher temperature, so the measuring tape is the thing, is the object that will expand at a greater rate of expansion. Okay, the measuring tape will expand more. The measuring tape will expand more. So the distance, the actual distance, didn't actually get further apart. No, the actual distance remained the same, but the measuring tape is now faulty. The measuring tape will now read a much less distance. Why? Because the graduations are further apart, because it expanded. So the distance between the 10 centimeters and 20 centimeters isn't actually 10 centimeters. No, the distance has actually increased. It could be, for example, 11 or 12 or 13 centimeters. Why? Because due to thermal expansion. Okay? Due to thermal expansion. Okay. Yeah. Question 16. It's kind of cancelled. It's kind of cancelled, but you actually need to know that the lower fixed point, okay, that the melting point, the freezing point is 0, and that the boiling point is 100. Okay, you wouldn't be asked about thermometers, but you would be asked about the melting point of ice, about the boiling point of water, which is 0 and 100. Okay, which row describes the process of melting? Yeah, this is quite easy. Yeah. How can we how can we define the melting process? The initial state, was it liquid? No, it wasn't liquid. Definitely was solid. The final state, is it a gas? No, it's a liquid. Does the temperature change? No, it doesn't change. It remains at what? At 0 degrees Celsius. Yes. Hmm. ماشي حلو. We have 4 campers. Okay. They use different rods. Which material is the best choice to prevent their hands from getting too hot? They do not want their hands to get too hot. Definitely they would use wood. Yes, a poor conductor. Yes, thank you. Excellent, excellent. Yes. Question 19. A beaker. Yalla. A beaker of water is heated and thermal energy travels through the water by convection. Through the water by convection. What happens to the density of the water as it heats up? As the density is heated, as the water is heated, what happens to the density? Density increases. No, actually, the density decreases. Why does the density decrease? We know because the volume increases. Excellent, you're all correct. And the heated water moves upwards. Yes, the heated water moves upwards. Excellent. Yes, bro. Hmm. Which labeled section is a wave front? Wave front. Only one wave front. Which labeled section is a wave front? Uh, which labeled section is a wave front? Okay, so B is actually wrong. B is wrong. This is wrong. Why is B wrong, يا شباب? B is a wave length. B is a wave length. Okay, B is a wave length, but C is a wave front. One of these lines, okay, one of these lines is a wave front. We call them wave fronts. Okay, that's the name. Okay, that is the name of this line. These perpendicular lines. What do we call them? We call them what? We call them wave fronts. Okay, question 19. Convection. What happens during convection? Okay, if you have a question during convection, what happens? The volume of the water, what happens to the volume? It increases, so the density decreases, and the hot water, okay, the hot water moves upwards. The hot water, the heated water moves upwards. Okay, yeah. Question 21 again. We need one wavelength. Very easy. What is one wavelength? Hmm. Distance from. Okay. Hmm. Yeah. One wavelength. This question would be, can it be from 1 to 2? No. It has to be from 1 to 3. Yes, excellent. It has to be from 1 to 3. Okay, good. Question 22. Angle of incidence and angle of reflection. That's very easy. Hello, angle of incidence. Can it be P? Can't, cannot, cannot be P. This is the angle of incidence, Q. What about the angle of reflection? Definitely it is R, yes. Angle between the incident ray and the normal, and the angle between the reflected ray and the normal. Uh, question 23. Okay, this is a nice question actually. Which, okay, which diagram shows rays of light, okay, through a converging lens in a camera? In a camera. حلو. Excellent. حلو. Yes. In a camera, okay, the lens would always invert the image. صح? The image would always be inverted. So we can just cancel out B and D. The image has to be, the image has to be inverted. Would the image be diminished or would it be enlarged? It would be diminished. Okay, you just think about it. You're taking an image with your mobile phone. You're taking an image of your friend, for example, and the image on your phone is, for example, what, 10 centimeters, 15 centimeters long? Is your friend 15 centimeters long? I do not think so. I don't think so. So definitely the images that you take with your phone, with your camera, what happens to these images? They get diminished. They are always smaller. Cameras, what do? They decrease the length. Okay. The image, what happens to the image? The image is much smaller than the actual object. It's diminished. Which statement about microwaves is correct? Yallah, microwaves. Microwaves, are they longitudinal? No, they're not longitudinal. Are they... the frequencies of microwaves are greater than the frequencies of visible light. Rami looks great. Microwaves and light. The frequency of the light is actually greater. So this is wrong. The speed of microwaves is equal to the speed. Yeah, this is the correct answer. Definitely, this is correct. Okay. Um, Rami looks great. As you're moving this way, what happens? The frequency increases and the wavelength decreases. But as you're going the other way, what happens? The frequency decreases, but the wavelength increases. We have a boat which sends off a signal to the seabed, okay, and then it is reflected back. The sound reaches the boat again after 1.3 seconds. It has a distance of 1,000 meters. Can I find the speed of sound in the water? How can you find the speed of sound in the water? This is an echo. Yes, this is an echo. How can we find the speed in echo? Yalla, speed equals 2 distance over time. 2 times 1,000 divided by the time, which was 1.3. صح? 2 distance over time, which would be, yes, C. Okay. 2 distance over time. Echo. Yeah. Question 26. Which action will not magnetize the rod? This is cancelled. Question 26 is cancelled. It has been removed. Question 26 has been removed. Question 27. The ends of 3 metal rods are tested by holding end Q of rod 1. So we take rod 1, okay, end Q. And you put it near end R, and then near end S, and then near T, and then near U. صح? When Q was near R, it attracted R. When it was near S, it attracted S. Then when it was near T, it attracted T, but when it was near U, it repelled U. Okay, it attracted R and S, attracted R and S. It attracted T, but it repelled U. Which metals are magnets? Okay, which of these metal rods are magnets or is a magnet? Okay, could be one, could be two, could be all of them. Which of these metal rods could be a magnet? Rod one only. Rod one, I think it's a magnet. Why? Because it's attracting and repelling. Okay. Could rod two be a magnet? Huh? Could rod two be a magnet? When you think about it, it was attracted from both sides. صح? It was attracted from both sides. So could it be a magnet? No, it cannot be a magnet. Why cannot it? Why? Why can't it be a magnet? Why can't it be a magnet? Because when you attract from both sides, then it has to be iron. It has to be unmagnetized iron. Rod 2 is iron. Why? Because it was attracted from both sides. What about rod 3? Well, it could repel, it attracted from one side and it repelled from the other side. So, yes, it could be, or it's definitely a magnet. In this case, definitely both of them, rod 1 and rod 3, are magnets. Why? Why? Okay. When you repel, okay, when Q repels you, when Q repels U. This means that they both have the same, think about it, huh? They both have the same pole. For example, Q was north and U was north, or south and south. This means that rod 1 and rod 3, they are both magnets. In order for a rod to have a pole, this means that the rod has to be a magnet. So both rods are now repelling, meaning that both rods are magnets. Rod 1 and rod 3 only. Rod 1 and rod 3 only, and that's it. Okay? Hmm. Okay, حلو. Which statement about a voltmeter is correct? يلا, voltmeter. It measures the current. Yeah, definitely. Voltmeter. It cannot measure the current. Huh. It measures the potential difference. حلو. Across a component and is connected in series. لا طبعا, it's not connected in series. Huh. It is connected in parallel. It has to be connected in parallel. Yes, D. Thank you. Yes, it has to be connected in parallel. Yeah, question 29. Four wires are made from the same metal. Which wire has the lowest, the least resistance? Which of these wires has the least resistance? What should we do to the length? What should you do to the length? You need to decrease the length. The shorter, the better. Whenever you have a shorter wire, the resistance would decrease. What about the wire? What about the diameter of the wire? You need to increase. You need to increase the diameter of the wire. So it would be B. Yes, excellent. I like this question, question 30. Can you find the circuit diagram for this arrangement? Can you find the circuit diagram for this arrangement? Okay, a lot of interesting answers. Okay, some of them might be right, some of them might be wrong. Okay, let's check them out. Are they all in series, for example, like in D? Are they all in series? Definitely not. Why? Because it's not the same wire. It's not the same. The wire was cut at this point. The wire was cut at this point, so they are not all in series. Are they all in parallel, as in C? No, they're not all in parallel. Okay, one of them is in series and two of them are in parallel. I actually just said the answer. One of them. Okay, so they're not all in parallel. Could it be B or A? Huh? Yes, it could be B or A, but B is actually wrong. Why is B wrong? Because these two, okay, I know it's a bit difficult, okay, but let's say let's just draw it. These two are drawn in parallel. These two are in parallel. Let me draw it quickly. These two are in are in parallel. They are in parallel. And then this one is all by itself in series. So you have two in parallel and then one in series, which would be A. Yes, it would be A. excellent. Okay, excellent. Yes, bravo. حلو. Question 31. Huh. The least, the smallest combined resistance. Which of these would have the smallest combined resistance? Okay, definitely D and C are wrong. Yes, definitely we have to cancel out C and D. Is it A or B? Huh? Yes, it is A. Why? Because the combined resistance has to be less than the least resistor. Oh, less than the least resistor. Oh, which is A. Less than the least resistor. This is the correct answer. In which case, this would be less than 5. Hmm. You have a variable resistor and another fixed resistor. Which row? Okay, the resistance of the variable resistor is increased. The resistance of this variable resistor increases. Resistance increases. What happens to the voltage? We know. We know that as you increase the resistance, what happens to the voltage? The voltage increases. Voltage increase. But what about the voltage of the other component? What about the voltage of the other resistor? The resistor, the voltage will will decrease. The voltage will decrease. Again, very simply, as you increase the resistance, what happens to the voltage? The voltage increases. صح؟ طب as you increase one of the voltages, what happens to the other voltage? It decreases. It has to be C. Yes, excellent. It has to be C. Resistance increases, voltage increases. So the other voltage would be less. It would decrease. Yes, excellent. Okay. Okay. Question 31. Again, quickly. Combined resistance in parallel circuits. Combined resistance in parallel circuits. What happens in parallel circuits? Okay. They decrease. What happens to the combined resistance? It decreases. So, for example, in D, the total resistance would be 15. In C, the total resistance would be 20. In B, it would be less than 10. And in A, it would be less than 5. In A, it would be less than 5. So that's why it would be the least resistance, the least combination of resistors would be in A. Okay? That's the whole point. In parallel resistors, what do we do? Parallel resistance, what do we do? We just say that the resistance is less than the least resistance. In question 32, the current decreases. Yes, yes, the current decreases. Okay. But he's not asking about the current, so I don't care about the current for this question. Yeah, question 33. We have a current in the kettle, okay, which is 10 amperes. And you have a 13 fuse ampere, which protects this kettle. If you replace this 13 fuse ampere with another 3 fuse ampere, what would happen to the kettle? What would happen to the kettle? Hmm. Would anything happen actually to the kettle? Would the kettle be damaged, for example? Hmm. If you remove the 13 fuse ampere and add another 3 ampere fuse, what do you do? What happens? The fuse melts and the kettle might be damaged? No. The fuse melts and the kettle is undamaged? Yes. Yes. The fuse does not melt, but the kettle fails to work. Actually, this is wrong. Okay. Someone said D. Okay. D is actually wrong. Why is D wrong? Because the fuse definitely will melt. Why? Because the kettle needs, okay, the kettle requires 10 amperes to work normally. Okay. It does require 10 amperes. So what will happen if it suddenly, hmm, takes 10 amperes, what will happen? The fuse will instantly melt. Will the kettle be harmed? No, nothing will happen to the kettle. Nothing will happen to the kettle. It will be undamaged. Okay. A student wishes to demonstrate electromagnetic induction. He has a magnet and connecting wires. Which other apparatus does he need? Which other apparatus? Yeah, this is quite easy. Which other apparatus would he need? Electromagnetic induction. induction. What do I mean by induction? يلا think about it كده. Electromagnetic induction. What other apparatuses might he need? يلا think about it. To induce a current. Okay, you need to induce a current. You need to produce a current. You need to generate current. Do you need a battery? Huh? You don't need a battery. You need to generate this current, so you do not need the battery. Okay, you do not need the battery. Yes, you do need a voltmeter. Why? Because you need some indicator to tell you whether there is a current or not. Okay, whether there is a voltage or not, whether there is an EMF, whatever. But you need some indication, but you do not need a battery. Okay, if you use a battery, this wouldn't be electromagnetic induction. You're not producing electricity due to some kinetic energy. No, you're producing energy from the chemical energy inside the battery. So this would be wrong. It wouldn't be electromagnetic induction. It would be a simple circuit. Okay? Yeah. Question 35. The diagram shows a transformer connected to a 240 volt AC supply. Very straightforward. We have a transformer. Okay, we have all of the inputs. Okay, you only need to find the potential difference across the secondary coil. Can I find the potential difference? Yes, I only have one equation. VP over NP equals VS over NS. We have the VP 240, VS 60. Yalla, can someone calculate it? 240 and 60. Can I find the VS? Yes, I need to find the VS over NS, which is 30. Very simply, cross multiplying 240 times 30 divided by 60 would be 120 volts. Step down transformer. Step down transformer. Okay, good. A current carrying coil is placed in a magnetic field. This coil has a current passing inside it. There's a current in this. Which effect does the coil experience? Nice one. Which effect does this coil experience? What will happen to this coil? What will happen to this coil? A coil with a current inside it, and this coil is placed inside a magnetic field. Will it change its shape? I guess not. Will it change its weight? Why would it change its weight? طيب, will it experience a resultant force or will it experience a turning effect? Okay, will it experience a resultant force or will it experience a turning effect? Yes, it will experience a turning effect. This coil, this is a DC. Yes, thank you. This is a DC motor. Yes, excellent. Okay, this is a DC. What does a DC motor do? It rotates. It keeps on rotating. Turning effect. A turning effect. But when could you say resultant force? If it was a wire, for example, if it was only one wire, what would happen to this one wire? It would either move upwards or downwards. Okay, then you could say it would experience a resultant force. But since it's a coil, what will happen to this coil? It will keep on rotating. It will keep on rotating in one direction, such as the fan. Okay, we all have fans. We all have electric fans. These fans, what do? They are DC motors. They use the current inside the coil to keep on rotating in one direction. Okay, how do we know it's a DC motor? It's a DC motor because there's a current passing in the coil. Okay, when you say there's a current passing in the coil, okay, or a current carrying coil, it's the same thing, huh? When you say that it's a current carrying coil, what do you say? What does this mean? It means that it is a DC motor, okay, that it will move, that there will be some sort of motion. But since it's a coil, so this motion will cause a rotation, not just any force. It wouldn't just move upwards or downwards. It would cause a rotation. Okay. No, we don't have any AC motors. Okay, we do not have any AC motors. We have only DC motors, or the other thing is called AC generator. A generator. This is not a generator. When do we generate? Okay, such as the question in 30. Which one? Okay, induction. Okay, when you say induction, when you induce a current, when you produce, when you generate a current, This is when you say, oh, it's an AC generator. Okay. When you move the wire to produce a current, this is called an AC generator. This is called electromagnetic induction. But for this case, the wire moved by its own, okay, on its own. How did the wire move on its own? Due to the current. Due to what? Due to the current passing in the wire. And while this wire was inside the magnetic field, it experienced a turning effect. Okay? I hope it's clear by now. Question 37, very easy. Which statement about the structure of the atom is correct? The structure of the atom: negative electrons surround a neutral nucleus. لا, nucleus is never neutral. Negative electrons surround a positive neutral. ماشي, okay. Negative electrons surround a positive nucleus. Okay, this could be correct. Positive what? It has to be B. Definitely has to be B. Question 38. What are isotopes of an element? Again, isotopes. What do I mean by an isotope? Atoms, huh? Of the same or a different, okay? Same or a different element. Isotopes are definitely the same element. The same element. Different number of protons. If it had different number of protons, it would have been a different element. So definitely same number of same element, same protons, different neutrons. Question 39. Question 39. We had the counter. Okay. The sample is removed and the counter then shows a background radiation of around 4 counts per minute. Okay. We had the sample. We removed it. Okay. You removed this sample. And the background radiation was about 4 counts per minute. What's the best estimate for the average count rate due to the radioactive sample? Due to the radioactive sample. How can I find the best estimate due to the radioactive sample? Okay, how can I find it? It's quite easy. Okay, quite easy. Okay, how can I do it? How can I find it, Shabab? You can for this question, you can. I'm sorry. Yes, you can find the average. You can find the average. What do I mean by finding the average? You can add them up. 106 plus 96. Can someone help me with this question? 106 plus 96 plus 98 plus 100 divided by 4. What is the average of this? Can I find the average? Yes. 106 plus yes, it would be 100. Excellent. Thank you. It would be 100. So the average of these readings is what is 100. If you remove the background radiation, if you remove the 4 counts per minute of the background radiation, it would be 96. 100 minus 4 is is 96. Okay? 100 minus 4 is 96. Okay? That's it. Okay? Any questions? You just need to find, you just need to find the average and then subtract the 4 counts per minute, which is the background radiation. Last question. Last question. 4 students are discussing ideas about radioactive decay. Which student's statement is correct? Which of these statements is correct, Shabab? When a beta particle is emitted, the nucleus remains unchanged. When a beta particle is emitted, the nucleus remains unchanged? No, it actually changes. When an alpha particle is emitted, the nucleus changes to that of a different element. Yes. Okay? Yes. When a gamma ray is emitted, the nucleus changes to that of a different element? No. Only when you emit a beta or an alpha particle. Stable nuclei are dangerous because no, stable nuclei are not dangerous. Only unstable nuclei are dangerous. So the only answer would be B. It would be B. Yes, excellent.